In this tutorial, we're going to show you yet another way to calculate the empirical formula of a compound. Woohoo! In the last example, we started out with grams of each element in the compound and we converted that to moles. In this case, we don't have grams. All we're told is the percent composition of a compound. In this example, we have 65.2% scandium and 34.8% oxygen. Your job is to figure out the subscripts in the formula. Now, you may be wondering why it is that we have so many different ways to calculate the empirical formula. And the answer isn't that your chemistry teachers are just simply trying to give you extra work to do. The reason is that different instruments that are used in the laboratory give us different information about the compound. A common tool that's used to help to determine the empirical formula of compounds is called the mass spectrometer. This device doesn't actually tell you the exact masses of the elements, but it does give you the relative abundance of one element to the other, as is in this example. So you would generate a graph that looks kind of like the one I just drew here, and you would get these numbers. So how do we proceed from here? Well, the answer is it turns out to be pretty easy. You just need to know to make a little assumption here. And the assumption we're going to use here is that you have 100 grams of the compound. And the reason for that is that, given that we're having a percentage here, that means that we can figure out really easily how many grams of each element would be in that compound. 65.2 grams would be scandium. Now, it's just like the problem like we had before. You simply need to divide that number by the molar mass of the element. That gives you 1.49 moles of scandium. And do exactly the same thing with the oxygen. So 34.8 grams of oxygen divided by the molar mass of oxygen. And from that we get that we have 2.175 moles of oxygen. Okay, so again, this is now just like the problem that we saw before. We need to find the simplest whole number ratio of these two elements. So we're going to divide the moles here. But I would make a suggestion, and that is that it's easier if you take the larger number, in this case the moles of oxygen, and divide that by the smaller one. This ends up giving you ratios that are a little bit easier to figure out. In this case, the ratio comes out to be about 1.5 to 1. Now, you can't really have 1.5 oxygen atoms for every one scandium, so we need to turn this into a reasonable whole number ratio. We're going to do that by multiplying the top and bottom of that fraction by 2. This gives us a whole number fraction of 3 to 2. It's important to keep track of what element's what. The 3 here refers to the oxygen, and the 2 refers to the scandium. That means the empirical formula of this compound is SC2O3. Now, if you were asked to name this compound, you would have to figure out the charges on each of the elements. We all know that oxygen is almost always -2, and that gives us -6 on the right side of that element, on that compound rather, and that means that the charge on the scandium would be +3. The name of that compound then is scandium, Roman numeral 3 oxide. And that's basically how you can determine the empirical formula given a percent composition. It's really not too bad once you learn that little trick about the 100 grams. So there you go.